All right, so we're back. Advisory, once again, you can say hi, advisory. Oh, that was funny. Okay, now, all right, now they're back to being quiet. So we were on number 12. We are accelerating the wooden block because of the acceleration due to gravity on Earth, and that is 9.8 meters per second squared. That is something you have to know for the final. You have to know that number. And when you multiply those two together, you get 2.156. Now you realize this is according to Cam's work, so hopefully this is all right. You get 2.156 newtons, and a newton is a kilogram times a meter per second squared, so that makes sense that these shouldn't cancel. And I would also accept, besides that, I'd accept 2.156 kilograms times meters per second squared. All right, number 13 is essentially the same problem, but now you're on Mars instead of Earth. So the acceleration due to gravity is going to change, but its mass is not. So it's still going to be 0.22 kilograms. The acceleration due to gravity on Mars is 3.72 meters per second squared. And that makes sense because Earth is bigger than Mars. And the more mass something has, the more gravitational attraction it has. The moon would be even smaller, and there would be even less gravity on the moon. All right, so we now just multiply these two numbers together, and you're going to get a force of 0.818 newtons. And if we do a common sense check, it weighs less on Mars than it does on Earth, and that's what we would expect to be the case. So that moves us to the last problem. Which is number 13, or number 14. And find the force of a car that is accelerating at 32 meters per second and has a mass of 2,200 kilograms. So the equation is force equals mass times acceleration. You may need to know the force triangle. Force equals mass times acceleration. Mr. Gerard is in there sawing away. I don't know if you can hear that. And so we're covering up force. It's going to be mass times acceleration. So the mass is 220 kilograms. And that unit is fine because force is measured in kilograms, right, in newtons. And newtons is a kilogram times a meter per second squared. We multiply that by the acceleration, which we said was 32 meters per second squared. And when you do the math on that, you're going to get what? 64,640. 64,640, and our units will be newtons. All right. Say goodnight, Gracie.
What? Good night.
Good night, Gracie.
There you go. That's the joke.